Okay, so in this tutorial here, I'm just going to quickly introduce to you how we're going to be using a multimeter here. We have our multimeter here. Currently it's off. Notice multimeters here can sense both direct current as well as alternating current here. Because the spontaneous reactions are expected to proceed just in one direction, we're just going to be using the DC side here. Depending on sort of how large I expect the voltage is going to be here, I can sort of set the maximum voltage here. Currently, I have an electrochemical cell here made out of a copper solution, copper electrode, a zinc solution with a zinc electrode here. It is connected with the salt bridge here. You can see what happens if I pull out the salt bridge afterwards. As I've done this here before, I'm just going to switch this here to the 2000 millivolt setting here. And therefore, this is going to actually max out at 2000 here. If this is currently giving me a voltage, it would actually give me a number here. So I'm just going to wiggle the electrodes around here to make sure it's giving us a reading. Again, we're maxing out currently at 2000 millivolts, or 2 volts for short. So this one can be read as 0.623 volts, or you can say 624 millivolts there. As I just dial it smaller here, let's say this maxes out at 200. Oh, it's more than 200 millivolts, so I need to have a bigger setting, and so on and so forth. You can play around with how you max out this detector here. Okay. There are other things we can read on the multimeter here, but for us, we really just need to see this direct current voltage here. For the leads here, I've connected here one to this VA port, and the other is a COM port. It doesn't matter which you have as your red wire or your black wire. That's just the plastic coating along the wire itself, and basically it helps you identify which is the anode and which is the cathode. Okay. So currently here I'm generating, this is a battery voltage of about we had 600 millivolts. It's finicky here because it's depending. Right now my powder isn't fully dissolved. Okay, so as that powder dissolves a little bit, it's actually going to fluctuate in terms of voltage. But hopefully here we have a we're tapping the external voltage here. If I pull out the salt bridge here, hopefully it responds directly here. And you notice that the voltage dies away to 0. Although the half reactions are wanting to occur, if I don't have the salt ions, right now this is potassium nitrate inside here, if I don't have the salt ions to actually counterbalance the charge, no reaction is happening. And then as I put it back in here, again I'm just going to wiggle it around here, we should be able to get a voltage back. And there we go. So it is a little bit finicky here. Sometimes the electrode plates here also are coated with some unwanted metal, so you just want to play around. Make sure that the electrode is actually in contact with each solution here. Make sure that the U-tube is actually connected at the top. If the U-tube here starts leaking, the first part that's going to be disconnected is actually the top part. Just pull out this U-tube here so you can see a little bit better here. But this salt bridge here, essentially, you see with the multimeter, it sort of works as an on-off switch here. I'm just going to pull out this U-tube here. Again, the voltage is dropped to 0. And then the part I was talking about here, make sure your solution is connected at the top here. If your solutions are only up to sort of the neck, so this U-tube here, and they're not connected, that essentially means there's no salt bridge in solution. All right? So it's just a quick tutorial of how we're going to be using a multimeter here. We are running a spontaneous chemical reaction and getting some positive voltage off of this. If I can just quickly swap out these electrodes here, if I accidentally have my electrodes on the other ends here, so the electrons are actually being read the opposite way here, you should be able to actually read the same voltage but negative. The negative just implies that the electrons are actually moving in the opposite direction. And again, being a little bit finicky here, but hope they get the idea. Okay. So we get that same millivolts that we have, but it's negative just to indicate that the electrons are actually traveling in the opposite direction. All right? Thanks, guys.